Good morning, students. So today we will discuss about the new chapter. So that is some basic concepts of chemistry. It's been very important chapter. So first of all, we should go for some basic concepts. So that is the matter. Matter, it is nothing but you people already studied in the 10th only. The matters are nothing but anything that will be occupy space and has mass. For example, this chalk, it has its own mass. If it will be placed somewhere, that will be occupy this portion of the space. So this is a mass, this is a matter, right? And it has mass, and this is nothing but the matter. If I will go for this scale, it has its own mass. If I will be placed somewhere, it will be occupy some amount of and space. That one we are called the matter. Matter is nothing but anything that will be occupy space and has the mass. If we go for example, the book is a matter, the air is a matter, the water is a matter, the chalk is also been matter, right? So this matter, it has been again classified into the solids, liquids, solid, liquid and the gas, right? So this matter, they have been classified into solid, liquid and the gases. If it become for the solid, this solid has its own definite volume and definite shape. This solid, it has been the definite volume and the definite shape, right? So here in this, the solid particles, for example, this chalk is also been a solid, this chalk is also been the solid, where particles are very closely packed, where particles have been closely arranged, right? It has the definite volume and the shape, right? So example, this chalk is an example for solids. This chalk is an example. The wood piece, right? So the wood piece is also been the example. So whatever the solids are there, they are in terms of air. So here the particles have been properly arranged. The particles are nothing but, so in terms of air, so the closely arranged, properly and closely arranged. So they are nothing but the solids. They have the definite volume and the definite shape. If it will come for the liquids, so here there is a definite volume but there is no shape. If it become for the liquids, so this liquids have definite the volume but there is no definite shape. Here in this, they will be give the shape wherever they will give the shape in which we have been placed the container, right? So we have been placed the liquids. So for example, if it will be placed this liquid into a jug, it will become to the shape of a jug. If it will become in terms of this, the liquid they have been placed into a test tube, it will be give the shape of the test tube. Understood? So in terms of here, so they have been the loosely in terms of here, they have been the loosely arranged. They have been the loosely arranged as compared to the solids. Example, the water molecule. And alcohol is also been liquid, right? So the mercury, the symbol of mercury is Hg. This has also been the liquid. It's only the liquid metal. It's only the liquid metal, right? So come for the gases. So here in this gas, so this gas particles, neither they have the volume, neither they have the shape, right? They don't have the volume, they don't have the shape, right? So they have been the loosely arranged particles. They will be move in any direction. Right? So if we go for the gas particles, so the nitrogen is a gas, hydrogen is a gas, oxygen is a gas, right? So these are nothing but, so the types of matters are nothing but, so the matter, anything that will be occupy space and has mass. So that one we are called the matter. It has been again classified into solid, liquid and gas, right? So it has been again, the fourth is also when matter is there. So that is the plasma, right? The fourth state of matter is nothing but the plasma, right? So here in this one, the solid, the particle, so that can be converted into the liquids, right? The solid that can be converted into the liquid and the liquid that can be converted into the solid. That's why just I wrote the arrow mark on both the sides. That's why I wrote arrow mark on the both the sides, right? So where the liquid has been again turns into the gas particles, right? So they have been the interconvertible. They are interconvertible. So for example, if we go for a solid ice, if will be melt into, if will be supply some amount of heat, it will be turns into liquid. The solid ice particles, ಸಾಲಿಡ್ ಐಸು ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಹೀಟ್ ಮಾಡ್ತೀವ ನಾವು, ಹೀಟ್ ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ, ರೈಟ್? ಅದೇ ಲಿಕ್ವಿಡ್ ನಾವು ಫ್ರೀಸ್ ಮಾಡಿದಾಗ, ಫ್ರಿಜ್ಜಲ್ಲಿ ಐಸ್ ಲಿಕ್ವಿಡ್ ಹಾಕ್ತೀವಿ ತಾನೇ ನಾವು, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಐಸ್ ಕ್ಯೂಬ್, ಸಾಲಿಡ್ ಐಸ್ ಕ್ಯೂಬ್ ಬರುತ್ತೆ ನಮಗೆ. ಸೊ ದಟ್ ಈಸ್ ಏನಾಗುತ್ತೆ, ಕೂಲ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿ ಟರ್ನ್ಸ್ ಇಂಟು ಲಿಕ್ವಿಡ್. ದಟ್ಸ್ ವೈ ಇಟ್ ಹ್ಯಾಸ್ ಬಿನ್ ಇಂಟರ್ ಕನ್ವರ್ಟೇಬಲ್, ರೈಟ್? ಸೊ ದ ಸಾಲಿಡ್ ದಟ್ ವಿಲ್ ಬಿ ಟರ್ನ್ಸ್ ಇಂಟು ಲಿಕ್ವಿಡ್, ದಟ್ ಈಸ್ ಅಂತ ಮೆಲ್ಟ್ ಆಗುತ್ತೆ, ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ, ಮೆಲ್ಟ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಲಿಕ್ವಿಡ್ ಇಫ್ ವಿಲ್ ಬಿ ಅಗೇನ್ ಸಪ್ಲೈ ಹೀಟ್, right? So if this liquid again I will be supply heat na supply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, it will be turns into gas, right? So water na boil ಮಾಡ್ತೀವಿ, ಮನೇಲಿ ಗೊತ್ತಿದೆ, right? So water na heat ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, it will be turns into the vapor state ಗೆ ಬರುತ್ತೆ, it will be turns into the gas, right? ಅದೇ ಗ್ಯಾಸ್ ನಾನು ಕೂಲ್ ಮಾಡಿ ಕಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ. ಕೂಲ್ ಮಾಡಿ ಕಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಕಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಗ್ಯಾಸ್ ಇರೋದೇನಾಗುತ್ತೆ, ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ. ಮಾರ್ನಿಂಗ್ ನೋಡಿರ್ಬೇಕು ನೀವು, ಮಿಸ್ಟ್ ಥರ ಬರುತ್ತೆ, ಕೂಲ್ ಆಗಿ ಟೆಂಪ್ರೇಚರ್ ಕೂಲ್ ಆಗಿರುತ್ತೆ ತಾನೆ. ಸೊ ವೇರ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಏರ್ ದ ಮಿಸ್ಟ್, ದ ವೇಪರ್ಸ್, ವಾಟರ್ ವೇಪರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಗೊತ್ತಾಗುತ್ತಾನೆ, ರೈಟ್? ಸೊ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಏರ್ ದ ಸಾಲಿಡ್ ಹ್ಯಾಸ್ ಬಿನ್ ಟರ್ನ್ಸ್ ಇಂಟು ಲಿಕ್ವಿಡ್, it's called melting. So this liquid has been turns into gas, it's called boiling, right? So where in terms of air the solid has been directly turns into the gas, the solid has been directly turns into the gas. So this one we are called sublimation ಅಂತ ಹೇಳ್ತೀವಿ. This one we are called sublimation, right? So sublimation is nothing but where the solid has been turns into the gas, right? So for example, the best example is nothing but we people already saw, ನಿಮಗೆ ಗೊತ್ತಿದೆ ಅಲ್ಲ, camphor. The best example is camphor, ಕರ್ಪೂರ ಅಂತ ಹೇಳ್ತೀವಿ, ಕರ್ಪೂರ, right? So when the camphor has been burned, it will be not turned into liquid, directly it will be turns into the gas, directly it will be turns into the gas. That one we are called and sublimation, right? So these are been nothing but the types of the matter, right? So this matter, it has been again classified into, so the two important types. So that is the matter, the pure substance, the matter, it has been again classified into, that is the pure substance, and mixture. Pure substance and mixture. So this pure substance, it has been again classified into two types. So that is an element and the compound. Element and compound. This mixture has been again classified into two types. That is homogeneous mixture. This is heterogeneous mixture, right? Just we'll discuss one by one. So this matter, it has been again classified into the pure substance and the mixture. This pure substance, it has been again classified into elements and the compounds. This mixture, it has been again classified into homogeneous mixture and heterogeneous mixture, right? So we already know what do you mean by matter. Now we'll go for the types. So that is classification, that is the pure substance, right? So we'll go for the pure substance. Pure substance are nothing but, so the substance where the constant particle cannot be separated by its ordinary physical methods, right? I will give one example. The best example is nothing but, for example, the water, right? For example, the water, right? So the water is a pure substance. The glucose, that is and C6H12O6. So here in this water is a pure substance. So here in this substance, the constant particles like hydrogen and oxygen, so that cannot be separated by simple physical methods. ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸಪ್ರೇಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಅಂತೇಳಿ. ಹೈಡ್ರೋಜನ್ we can't be separate, oxygen we can't be separate, not by the physical method. Simple methods ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸೊ ಎರಡು ಕಾನ್ಸ್ಟೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ನಾನು ಸಪ್ರೇಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. They are called pure substance. For example, the glucose, so there have been the 6 carbon atoms and the 12 hydrogen atoms and the 6 oxygen atoms. So these atoms that cannot be separated by simple physical methods, they are called pure substance. What do you mean by pure substance? The constituent particle which cannot be separated by simple physical methods, which cannot be separated by simple physical methods, they are called pure substance. Example, the water, example, the glucose, right? Example, the methane, example, the ammonia. These are nothing but the pure substance which cannot be separated, its constant particle by some physical methods. They are called pure substance. So this pure substance, it has been again classified into elements and the compounds, right? So elements are nothing but, so these elements are nothing but, it has been made up of only one type of an atom. Nitrogen is an element, N2, nitrogen is an element. It should be containing only nitrogen. So many nitrogen molecules, so many nitrogen atoms, they are called elements. Elements are made up of only one type of an atom. Elements are made up of only one type of an atom. They are called elements. Nitrogen is an element. Oxygen is an element. Right. So hydrogen is an element. The sodium is an element. The copper is an element. It should be containing only one type of an atom. It should be containing only one type of an atom. They are called elements. Right. So water is not an element because it will be containing two different atoms. Because the water is made up of two different atoms. But water is a compound. Right. So what do you mean by element? Elements are nothing but, so elements are made up of only one type of an atom. Elements are made up of only one type of an atom. They are called elements. If it will come for compounds ಅಂತ ಹೇಳಿದಾಗ, so it will be containing two or more different type of atom elements. Two or more different type of elements combined to form a compound. Example, so the water is a compound. Water is a compound because so this one atom and this one atom, this one element, this one element. So these elements are combined to form a compound. Right. So water is a compound. The methane CH4 is a compound. Right. So ammonia NH3 is a compound. What do you mean by compound? The compounds are nothing but, it is made up of two or more different atoms. It is made up of two or more different atoms, or it is made up of two or more different elements. They are called compounds. Understood? It's been easy one, right? So just remember that one. Elements are nothing but, it is made up of only one type of an atom. It is made up of only one type of an atom, right? So if we take one cylinder, here in this cylinder that will be containing only nitrogen gas, it's an element. I will be take one cylinder, here in this cylinder they have been filled with the nitrogen, it's an element, right? And compounds are nothing but, it is made up of the two or more atoms. They are called compounds. Come for the mixture, right? So mixtures are nothing but where the constant particles that can be separated, the constant particles that can be separated by simple ordinary methods, they are called mixture, right? So the constant particles in marbodu separate marbodu by simple physical methods, they are called in terms of here, so the mixture, right? So for example, the air is an example for, right? So and then the sugar solution, right? And then crude oil, the crude oil. So these will be nothing but the mixture. Example for mixture: air, it will be containing oxygen, air it will be containing nitrogen, air it will be containing hydrogen, air it will be containing helium, neon, argon, noble gases. So these are in the mixture, right? So that can be separated, the mixture of gases, that one we are called mixture. The constant particle that can be separated by simple physical methods, they are called mixture, right? So in terms of here, this mixture has been again classified into the two important types, that is homogeneous mixture and heterogeneous mixture, right? So homogeneous mixture, homo means same, homo means same, the name itself indicates homo means same. Hetero means different, hetero means different, homo means same, hetero means different, right? So here in this homogeneous mixtures are nothing but the mixture which containing same type of constituent particles, the mixture which containing same type of constant particles. For example, the sea water, right? So for example, the sea, ಸಮುದ್ರ, ದೊಡ್ಡ ಸಮುದ್ರ ಇರುತ್ತಪ್ಪ, ರೈಟ್? ಸೊ ಜಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಒನ್ ಎಂಡಲ್ಲಿ ನಾನು ಏನಾಗುತ್ತೆ, ಜಸ್ಟ್ ಐ ವಿಲ್ ಚೆಕ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಸಾಲ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, and I will take one more the other opposite end ಅಲ್ಲಿ salt concentration ತಗೊಂತೀನಿ, ಸೇಮ್ ಇರುತ್ತೆ ತಾನೆ? ಅರ್ಥ ಆಗುತ್ತೆ ಹೇಳ್ತಿರೋದು, ರೈಟ್. ಸೊ ದೆನ್ ಐ ವಿಲ್ ಟೇಕ್ ದ ರೈಟ್ ಸೈಡ್, ಐ ವಿಲ್ ಟೇಕ್ ದ ಲೆಫ್ಟ್ ಸೈಡ್, ದ ಸೇಮ್, ರೈಟ್. ಸೊ ದ ಕಾನ್ಸ್ಟೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗುತ್ತೆ, ಸೇಮ್ ಆಗಿರುತ್ತೆ. ದೇ ಆರ್ ಕಾಲ್ಡ್ ಹೋಮೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್. ದ ಮಿಕ್ಸ್ಚರ್ ವಿಚ್ ಕಂಟೈನಿಂಗ್ ದ ಸೇಮ್ ಕಾಂಪೋಸಿಷನ್ ಥ್ರೂಔಟ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಪಾರ್ಟ್ಸ್. ಥ್ರೂಔಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗುತ್ತೆ, ಸೊ ಕಾನ್ಸ್ಟೆಂಟ್ ಪಾರ್ಟಿಕಲ್ ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ಐ ವಿಲ್ ಗಿವ್ ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್, ದ ಸಿ ವಾಟರ್ ಇರ್ಬೋದು. ಆ್ಯಂಡ್ ದೆನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ದ alloy is nothing but, so the brass is an alloy, the bronze is an alloy, the bronze is an alloy, right. The composition for this one is nothing but the copper and nickel, right. The composition this one, if assume it's an alloy ಅಂತ ಹೇಳಿದಾಗ ಏನಾಗುತ್ತೆ, this one alloy ಅಂತ ಹೇಳಿದಾಗ, so if we take the concentration of this one, ಈ ಪಾರ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತಗೊಳ್ಳಿ, ಈ ಪಾರ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎರಡು ಸೇಮ್ ಇರುತ್ತೆ ಆಲ್ಮೋಸ್ಟ್, right. That one we are called alloy ಅಂತ ಹೇಳ್ತೀವಿ. They have been the mixture which containing the same constant particle throughout, right. So heterogeneous ಅಂತ ಹೇಳಿದಾಗ ಏನಾಗುತ್ತೆ, so the mixture which containing different constant particle in different part, different constant in different part, right. So example is nothing but the muddy water, right. So for example, just I will take the beaker, one beaker ತಗೊಂತೀನಿ, ಅದ್ರ ವಾಟರ್ ತಗೊಂತೀನಿ, ಓಕೆ, ವಾಟರ್ ತಗೊಂತೀನಿ. ಇಫ್ ಐಲ್ ಆ್ಯಡ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಸಾಯಿಲ್ ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ. ಸಾಯಿಲ್ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಸ್ವಲ್ಪ ಹೊತ್ತು ಬಿಟ್ಟರೆ ಏನಾಗುತ್ತೆ, ಎಲ್ಲ ಸಾಲ್ಟ್ ಇಲ್ಲಿ ಸೆಟ್ಲ್ ಆಗುತ್ತೆ ತಾನೆ, ಅದು ಬಾಟಮಲ್ಲಿ ಸೆಟ್ಲ್ ಆಗುತ್ತೆ. ಅದೇ ಇಫ್ ವಿಲ್ ಬಿ ಟೇಕ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ಟಾಪ್, ರೈಟ್. ಸೊ ಟಾಪಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತೊಗೊಂಡೆ, ಬಾಟಮಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತೊಗೊಂಡೆ, ಡಿಫ್ರೆಂಟ್ ಇರುತ್ತೆ ತಾನೆ. ಕಾನ್ಸ್ಟೆಂಟ್ ಪಾರ್ಟಿಕಲ್, ಸಾಯಿಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗುತ್ತೆ, ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಜಾಸ್ತಿ ಸಿಗುತ್ತೆ ನಿಮಗೆ, ಇಲ್ಲಿ ಕಡಿಮೆ ಸಿಗುತ್ತೆ. ಎಲ್ಲಿ ಟಾಪಲ್ಲಿ ಕಡಿಮೆ ಸಿಗುತ್ತೆ, ಬಾಟಮಲ್ಲಿ ಜಾಸ್ತಿ ಸಿಗುತ್ತೆ, ಗೊತ್ತಾಗುತ್ತಾನೆ. ಸೊ ದಟ್ ಒನ್ ವಿ ಆರ್ ಕಾಲ್ಡ್ ಹೆಟ್ರೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್. ದ ಕಾನ್ಸ್ಟೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡಿಫರ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಪಾರ್ಟ್ಸ್, understood. So this one we are called heterogeneous mixture, right. So this is nothing but the classification of matter. So this matter that can be classified into the pure substance and the mixture. This pure substance has been again classified into the elements and the compounds. The mixture has been again classified into homogeneous mixture and then heterogeneous mixture, understood. It's been very easy and important also, right. So we go for next one. So that is decimal we'll go for decimal fractions or multiples. It's been very important, it's a basic thing, so that one you should remember. So that will be helpful for whole complete 2 years, right. So decimal fraction or multiples. So this one will go for multiples, and this is prefix, the multiple and then prefix, right. So if it is and decimal fraction, if it is 10 to the power of 15 minus 15, 10 to the power of minus 15, so the prefix is always femto. Remember that one, the prefix is always femto, remember, right. So if it is 10 to the power of minus 12, right, 10 to the power of minus 12, this is in terms of the pico, this is pico. If it is 10 to the power of minus 9, it is nano. 10 to the power of minus 9, nano. The prefix we should use picometer, nanometer, right. So in terms of here, if it is 10 to the power of minus 6, 10 to the power of minus 6, that is micro. 10 to the power of minus 6, micrometer, right. If it is 10 to the power of minus 3, milli. 10 to the power of minus 3 milli, right. So if it is 10 to the power of minus 2, that is and centimeter ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, 10 to the power of minus 2, right. So if it is 10 to the power of minus 1, this is deci. 10 to the power of minus 1, deci. If it is 10 is nothing but deca. Deca means 10, deca. If it is 10 square, if it is 10 square, hecto, if it is 10 square, hecto, understood? If it is 10 to the power of 3, 10 to the power of 3, that is kilo, right? If it is 10 to the power of 6, mega. If it is 10 to the power of 6, mega. If it is 10 to the power of 9, giga. 10 to the power of 9, giga, right? So if it is 10 to the power of 12 plus 12, tera. If it is 10 to the power of 15, peta, understood? So these are nothing but, so that decimal fractions are multiples, right? So and their prefixes, it's been very important one. So the whole 2 years it will be helpful for the helpful in so the solving the problems, right? So we should go for the conversions in the problems. So if it is 10 to the power of minus 15, so that is femto. 10 to the power of minus 12, pico. Minus 9, nano. 10 minus 6, micro. Minus 3, milli. 10 to the power of minus 2, that is centi. Minus 1, deci. And 10, deca. 10 square, hecto. 10 cube, kilo. 10 to the power of 6, mega. 10 to the power of 9, giga. 10 to the power of 12, tera. 10 to the power of 15, peta. Understood? Right? This has been very important one. Right? I'll go one more thing. So that is the formula just to convert from degree to Fahrenheits and the Fahrenheits to degree. Right? So one more thing. So that one we will discuss next class. Thank you.